Hi people, today we are going to learn about the quotient rule technique. So we are going to use the given examples to understand more about the quotient rule. Let's go to our first example. Evaluate the first derivatives of y is equals to 3x squared plus 2x over 4x squared minus 3. The formula for the quotient rule is u prime v minus u v prime over v square. So we will let our u to be 3x squared plus 2x and our v will be 4x squared minus 3. Since u and v are all functions of x, we'll differentiate u with respect to x, which is 6x plus 2. Differentiating v with respect to x, you will get 8x. So u prime v, if you multiply the derivative of u times v and multiplying the derivative of v times u, divide by v square, you square the value of v. Our v is 4x squared minus 3. You will get 4x squared times 4x squared minus 3 minus 3, 4x squared minus 3. Ukisha square, we'll have 16x raised to 4 minus 24x squared plus 9. So u prime v, if you multiply the derivative of u times v, you will have 24x cubed plus 8x squared minus 18x minus 6. Ukisha fanya hivo, next is u times the derivative of v, which will give you 24x cubed plus 16x squared. So here next we will apply the quotient rule, which is u prime v minus u v prime over v square. You subtract, then you divide by v square, and the final answer will be negative 8x squared minus 18x minus 6 over 16x raised to 4 minus 24x squared plus 9. On to our next example. Y is equals to 2x squared minus 5 over x minus 1. We'll have our u to be 2x squared minus 5 and our v will be x minus 1, which is the denominator. Simply our u is the numerator and our v will be the denominator in simple terms. So since u and v are all functions of x, you differentiate u with respect to x, which is 4x, and v with respect to x, which is 1. So u prime times v will be 4x times x minus 1. You get 4x squared minus 4x. U times the derivative of v is 2x squared minus 5 times 1, which is 2x squared minus 5. If you square v, you will have x squared minus 2x plus 1. Applying the quotient rule, you get 4x squared minus 4x minus 2x squared plus 5 all over x squared minus 2x plus 1 which is 2x squared minus 4x plus 5 over x squared minus 2x plus 1 as the final answer. Example number 3. Y is equals to tan x. So tan x is the same as sin x over cos x according to the trigonometric standards. So we let sin x to be u and cos x to be v. Differentiating u with respect to x, you will have cos x. Differentiating v with respect to x, you get negative sin x. Applying the quotient rule, you will have cos x times cos x minus sin x times negative sin x over cos square x, which is equals to cos square x plus sin square x, which is the same as 1 over cos squared x. On to example 4. Y is equals to cot x, and cot x is the same as tan inverse of x, which is the same as cos x over sin x. So we let cos x to be u and sin x to be v. Differentiating u with respect to x, you get negative sin x, and v with respect to x, you'll get cos x. V squared is equals to sin square x, because our v was sin x. If you square sin x, you will have sin square x. Applying the quotient rule, you will have negative sin square x minus cos square x over sin square x, which is the same as negative 1 over sin square x. The reason as to why we are getting here negative 1, remember, according to the trigonometric standards, sin square x plus cos square x is the same as 1. So when we put here negative, it will be sin square x minus cos squared x. That is why we are getting negative 1, because of the negative. After that, we got negative 1 over sin square x, which is the same as negative cos x square x. 1 over sin square x is cos x square x. So because of the negative, we'll have negative cos x square x. You can try these examples to find the derivatives of these examples using the quotient rule. Thank you for watching my video. Make sure you like, share, comment, subscribe. See you in the next video. Na hapo kwa comment section mniambie mnataka nifanye nini next. See ya!